I wonder how big you allow your imagination to be. How big are your dreams? How wild are your ideas? Ideas bring change, and sometimes ideas are worth spreading. Change, of course, can come from anywhere. Since late 2019, the world and human society have been ravaged by the horrors of a once-in-a-century pandemic, COVID-19. It has changed the way that we eat, the way that we shop, the way that we learn, the way that we work, and the way that we do business. It has affected every aspect of our lives, and in many ways, it has made our lives more difficult and placed restrictions on our freedoms. One thing that it has been unable to quash, however, is our ability to be creative and innovate. Now, many people tragically have lost jobs due to the inability to function in a face-to-face context or a decline in sales. In response to this, however, we have seen the creation of new jobs, particularly online, and notably a rise in entrepreneurship. Many creative people have given up their routine 9-to-5 jobs and taken on the challenge of exploiting a newly created market need. One particular technology that has proven invaluable to those who have been developing new products is something called 3D printing. 3D printing allows the production of complex functional parts and prototypes on demand and has options that are affordable and easy to use. For those of you who are already familiar with 3D printing, it may not surprise you to learn that 3D printing has been a key technology in the fight against COVID-19. It's been used in the rapid production of PPE and medical devices, particularly where there have been interruptions in the supply chain. Before I proceed with the rest of my talk, I have a bit of a confession to make. I'm a bit of a sci-fi fan, though I'm sure you couldn't tell just from looking at me. When I was young, I enjoyed watching TV series such as Star Trek and was fascinated with the futuristic technologies that the characters interacted with. I wondered, would I see any of them achieved during my lifetime? Well, while we might not be whizzing around the universe faster than the speed of light in galaxy-class starships, some of those technologies have already been developed. Let me give you a few examples. Those of you with a fear of needles will be thrilled to know that the needleless injection devices found in the Enterprise's medbay have already been developed at MIT. We will soon be able to give someone a vaccination without any pain. The prospect of being able to speak to a spaceship and get meaningful answers seemed incredible at the time. Now there are a variety of different virtual assistant AIs to choose from, some of which can send messages to our loved ones or control the electronics in our home, or even order a pizza, remembering to hold the anchovies. The badges worn by Starfleet officers allow them to communicate over long distances with each other and their ship's AI. The watch that I'm currently wearing is one of many that can achieve this function and much more besides. In Star Trek The Next Generation, Lieutenant Commander Geordi LaForge was born blind and wears a visor that sends optical images directly to the optical nerves. Scientists in the Monash Vision Research Group have developed a device called Genaris that sends processed images to a device surgically implanted in the brain, allowing the user to see without being able to see or use their eyes. However, there are still many fascinating devices that we have yet to see developed. One that I'm really interested in is the Replicator. The Replicator was a machine that converted energy into matter, allowing the user to order whatever they liked within certain limits, and it would immediately appear. A very convenient technology. While we haven't quite got there yet, it may not be too long before we can see something almost as good. First, though, I need to give you a little bit of historical background in manufacturing. Prior to 1760, when you wanted a new item, you would typically buy something that was handmade by a skilled craftsman or woman, or for some items, made on a bespoke basis, that is, to order. If you could afford it, you would simply ask for what you wanted, and the item you received would be at least somewhat unique. And those kind of items would be passed down within a family as heirlooms. The first industrial revolution changed all this. A number of key technological advancements meant that machines powered by steam and water were suddenly able to do a lot of the hard labor jobs involved in manufacturing. And processes were invented that meant that items could be produced by machines. Machines didn't rely on years of experience and dexterity to control the quality of the work they produced. And they worked much faster. Craftsmanship and bespoke items began to see a decline because of the relatively lower costs of items produced by machinery. Through the development of production lines and computer-controlled machinery for manufacturing, what we have seen is an ever-increasing focus on something called the economies of scale. To put it simply, the cost of making each item becomes much cheaper once we produce more of that item. It's kind of like buying in bulk. What this has meant is that more people than ever before can afford to buy things, often things that we don't even need, but certainly things that we could never afford to pay a craftsperson to make for us. Unfortunately, this has also meant a change in our way of thinking about our belongings. It's much cheaper, thanks to the economies of scale, to buy new items rather than repairing what we already have, for all but the largest of goods, cars, for example. This means that we aren't as careful with our belongings as our ancestors were, and sometimes we even change our belongings just for the sake of a dopamine hit. We're happy to buy mediocre quality furniture that maybe isn't quite what we really want because we know we'll replace it in a few years anyway. But what if we could go back to the level of personalization that our ancestors prized without the huge price tag? What if we could make our belongings just the way we wanted? Would we cherish them again? Enter 3D printing, a technology that allows us to create 3D shapes from a variety of materials at the click of a button, based on designs on PC. In 1986, Chuck Hull patented a process which turned a liquid plastic material into a solid in thin slices, any shape imaginable. When those slices are produced one on top of the other, we get a 3D shape, a bit like this dinosaur puzzle. You can see the different layers. Chuck predicted that it would take 25 to 30 years for 3D printing to reach our homes. And he was right. Chuck's technology is still wildly successful, but another technology that's catching up is fused filament fabrication. It's a bit of a mouthful, I'm afraid. We call it FFF for short. This aircon pipe adapter that I bought online was made by FFF. This is an FFF printer. It's a bit like a hot melt glue gun attached to a robot. A plastic rod called filament is melted and pushed out through a nozzle, which is moved around to form thin shapes, building parts up layer by layer. These two technologies have become so developed and affordable that they are easily available to the average consumer. The majority of you here could start trying this tomorrow, perhaps at your local library. The industrial market is much more significant in terms of value, and the global market for 3D printing is expected to grow by up to 4 times by 2028. However, a lot of very interesting work is coming out of the hobbyist and home enthusiast community, and this may significantly affect the way the technology develops. Now, that brings us more or less up to date. So what's next? Well, plastic materials are useful. Sometimes we need to make something really strong. Sometimes we need something with special properties, such as good electrical conductivity or resistance to high temperatures. Sometimes we need to work with metals. Now, plastics were a natural choice for early 3D printing systems, since turning a liquid into a solid and vice versa tends to happen at temperatures no hotter than the inside of your oven. But for metals, there are bigger challenges. Most metals melt at very high temperatures. So we need things like electron beams, lasers, and furnaces to get them hot enough. It's pretty dangerous. Most of the more common commercial techniques also rely on having something called a powder bed. It's a big container full of metal powder. Now, metal powder is nasty stuff. You need to wear a full hazmat suit when handling it. Not really suitable for use at home. Now, some clever guys have developed filament-containing metal powder for the FFF systems we talked about earlier, but you still need to bake the parts in a high-temperature furnace to remove the polymer and bond the metal powder together. The filament is also not cheap. There are a lot of other techniques that scientists and engineers are currently working on to print parts from metals, such as material jetting. In material jetting, tiny droplets of liquid metal are squirted out of a nozzle and splat on a surface in thin layers to form both tiny and large parts. I'm proud to be part of a team here at the University of Nottingham, Ningbo, China, developing a new technique for material jetting called MDE, or metal droplet extrusion. This technique uses cheap metal filament and low-cost components to make tiny droplets of metal. It's quite possible that one day in the not-too-distant future, people will be using this in their own homes. One of the other amazing things about this kind of process is that you can make droplets of more than one material at the same time. This means that you can not only make complex parts, but even finished products in one go. The idea is not new. MIT built the Multifab back in 2014, a 3D printer that can simultaneously print up to 10 different kinds of plastic materials. So why am I interested in this? Well, if we're able to print not only plastics, but metals, ceramics, and other materials at the same time, we can print machines containing motors. We can even print robots, all in a single operation. I believe that soon we may be able to purchase designs and raw materials online and 3D print our own goods and food, rather than having them delivered. This sounds exactly like the kind of technology we were talking about earlier in Replicators. Speaking of Replicators, there was another sci-fi series that I enjoyed watching that contained something called a replicator, and that was Stargate SG-1. In SG-1, however, the replicators were not a harmless food and tool-making technology, but rather a race of self-replicating machines bent on universe domination. So, does the advent of self-replicating machines hail the start of the machine apocalypse? Well, maybe not anytime soon, but let's keep our eyes open and our shotgun axes sharpened, just in case. But seriously, what can we do now to prepare for the future? Well, according to the World Economic Forum, 65% of primary school-aged children will, in the future, have job titles that don't exist today. An increasing number of jobs are being taken over by robots and automated systems. New jobs are being created, particularly by and for those who are creative and determined enough to seek them. What can we do for our children in the face of this uncertain future? We need to help them develop relevant skills that will likely be useful and a resilient mindset. Personally, I believe that one job that isn't going away anytime soon is design engineering. While machines can optimize designs and make incremental improvements, I don't believe that AIs can truly understand human needs and develop products in response. Creativity is a vital ability for designers, engineers, scientists, and entrepreneurs. Creativity is something that our children have in abundance that we often lack as adults. One of the first things I teach my design students is that the peak age for creativity is 6. After this, it's a long downhill slope. The reasons for this are a little convoluted, so I won't go into them now. But often we are to blame as parents and educators. We tell children that things must be done in a particular way, rather than letting them experiment and find out what works. Or we get annoyed when they do things the wrong way. Now, I'm not talking about teaching our children about the moral kind of right and wrong, which is essential, but rather allowing them to find their own way of reaching a particular goal. I had to stop myself from telling off my son when he was younger, and he decided to take a slide puzzle apart and put it back together the right way instead of sliding the pieces around the board. He was finding an alternative solution to the problem. 3D printing is not only likely to be a significant technology in the future, but is also a great way to build creativity now. Being able to design an object on a computer and then touch it with your own hands is a very significant feeling and a learning experience. There are huge catalogs of parts you can download from the internet to get you started, but learning to use 3D design software to model your own parts is where the interesting part lies, and there are many good options available for free. Printing your first part is not too hard, but it does take a little patience. Printing good parts and getting it right takes time and practice. There are lots of variables and different ways you can customize the process. There are always new things to learn, but anyone can design and print amazing things. The only thing holding you back is your imagination. Thank you.